I hope at least one of you, so together you would be able to tell all the questions. So yeah, so please begin with the questions from last time. Yeah. Just one second, just one second. Yeah. Questions from, yeah, just, yes, yes, please say. You had to find, oh, this was one question. Oh, but before this, right, before this, was there any other easier question or anything? More, some, or anything? Just say any other question. Okay. Was there any other question? Mm, Nandini, is there any other question that we are missing? Oh, okay. Okay. So then let's do this problem. So yeah, so in this only, so all are related to this. Okay, so let's begin. So what have you guys tried? Just can tell. Any any things that you guys have got? So I see that A3 is also equal to 1. Yeah. So what have you guys tried? Just tell me. And Nagish, please try it now. So any ideas? Did you try to compute the first few terms and see anything? So what's A4? A4, anyone? A4 is 5. How is it 5? So A4 is, let's see, A4 is A3 minus A2. So that's minus 1. Okay. All right, so let's keep this here. Okay. And what is A5? Minus 2. So A5 is minus 2. So did you guys do this calculation? Nandini, what about you? Did you do these calculations? Okay, so always it means you have to do at least whatever you can in the problem. Okay, at least calculate the terms and see. So A5 is minus 2, and then what is A6? So again, minus 1. Just correct me if there is anything wrong. Okay. A7 again is 1. So anything you notice so far? Anything? Ah, that is a good thing. Satya, did you notice that? Or is it getting repeated? What is A8? Yes, it is getting good. Correct. It is repeated. Satya, did you notice this? So maybe you didn't compute enough terms. If you do compute enough terms, you will see it, right? Okay. So, Nandini, do you have an explanation as to why the pattern will keep repeating? Why will the pattern keep repeating? Yes. Perfect. That's right. It just depends on the previous two terms. That's an accurate reasoning. Now one can go in circles and say a lot of things, but what you have said is an accurate reasoning. Okay, that one and two come again, and therefore the third one has to again be one and again minus one because it only depends on the previous two terms. So it's almost like a proof. Satya, is the reasoning coming clear? What she has said. So it's a very nice reasoning in the sense, right? One and two is what we started with. We get one and just getting one is not a guarantee that the pattern will repeat. Okay, like we got a one here also, but that getting the two, and you can understand. Okay, all right. So that's a very good piece of reasoning. So we have sort of established that the pattern will repeat. Okay? So I suppose this is clear for all of us. If please tell me. Yeah. Because it's very important to write the reasoning, to be able to write the reasoning. Obviously, one has to say more accurately using induction, but this is good enough for now. Okay? It's sort of now it's clear that the pattern will repeat. Now use this to find an. So you find 100. So that should not be difficult now. But either ways, let's do this. So all of you try this. Let's see who can do it first. No, that's not important. Try it. One. Others have got anything? You're saying -1. Okay. Now let's see what Satya says. You're getting -1. Okay. So Nagesh, can you explain why you got -1? Uh, 96 term will be 2. Why will it be 2? Sorry, it will be. I lost the voice. It will be. Repeat. Sorry. Okay. I don't. So yeah, let's see. I didn't get it. Now you're getting 1. Why is it 1? So shouldn't it be 2? I mean, so it should be. So 100. Shouldn't it be A2 then? I don't know. Or oh, okay. So all right. So what I understand is A1, or is this all are we doing this wrong? What is it? Is that does the pattern repeat after every 7 terms, or I don't know. I'm not happy with the explanation so much. Nandini, can you give your explanation? Hmm. Hmm. Okay. Hmm. Right. So it is indeed -1. Yes. So the pattern is repeating every 6 steps. Right? Maybe Nagesh, this is what Nagesh was is saying, right? It's every 6 steps, right? So 100 is equal to, I mean, you should divide it by 6 and see, right? So 100 is, I know this is all very easy, but we should just be able to do it efficiently. Okay. Um, yeah. And so whatever it is, 6, and then there is 4. Obviously, Nandini's explanation is correct, but essentially the point is that it's repeating after every 6 steps, right? So A100 should be, if I'm not wrong, should be equal to A6. Sorry, I mean A100 should be equal to A4, right? Because wait, what is hold on. So uh, yes, right? That's correct. Yeah. Every 6 steps, right? So A1 is equal to A7. So the difference is 6, or the leave the names 1 and 7 leave the same remainder when divided by 6, all the same things. And then the answer is same. And so it will continue, right? So A100, 104 leave the same remainder when divided by 6. So it will be equal to A4. And then A4 is -1. Okay, so the pattern is 6 steps, right? And A1 is A7, so it is added by 6. Okay, so always the remainder uh, when divided by 6, you have to check, like A2 will be same as A8 because same 2 modulo. Okay, so this is a not, it's an easy question, but you have to be able to know that this kind of questions, and if able to do it uh, relatively fast, not like me. Okay, should you have to do it fast. Okay. If you do it like me, then you will not be able to complete. All right. So then this is fine. Um, so I had asked some other question, but now let me change that or whatever, update it, whatever, and let me ask this question. So find A1, A2, dot dot dot. Today I'm slightly unwell, not unwell, just very very tired. Okay? So yeah. So yeah, let's try this. Okay? Find A1 to A100, the sum. Now I'm looking for the sum. And don't worry if you have not done this kind of question earlier, try A1 plus A2, A1, I mean, C. Okay? We do have some insights into this sequence, but right. Just try it. I'll just drink some water and come. Okay. Okay. So any ideas? Okay, so you're getting 3. Let's see. So let's see what the others are. So now maybe you could take that this as a hint that maybe answer is 3. So again, to everybody, I will just say that this is a pattern. There is a certain again pattern which you have to look at. And so there's something. In many ways, this is slightly mysterious sequence. I don't know. Not, but yeah, let me also try something. Okay, good. So I'm also just to see something. Okay, all right. So Nandini, would you like to explain why is it 3? Oh, wait. But those are um uh, 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 okay. So let me write a bit of what you have said. So this a sub minus 1 concept is actually very useful sometimes. In this case, maybe it's not needed, but either ways, let's see. So this thing and so Nandini, are you saying something like this? You have to extend it like this, or mm, okay? How do they get cancelled? So you have not written a2 as a1 minus a0. Okay, interesting. Huh? Okay, and then you've written 800. Now let's see this method because these are the methods you have to learn, like the different techniques different people are giving. That's important. Okay, so how will the terms get cancelled? Mm-hmm. Mm-hmm. Right. Yeah. So you are extending the okay. I understand. So you meant you don't write it explicitly, but you are using the yeah. You are applying a3. Oh, good. Okay. Yes, right. I understand. That's good. So then you're left with this a minus one, a sub minus one. Perfect. Good. So that's these are the things. Good. Okay, this is a nice thing. So what do you do with this? Hmm? No, but a sub 1 also seems to cancel, or is it not? In what way is it left? Uh, no, but a sub minus 1 is not 2. Is it? Is what is it? Is it 2 or what? What is it? Minus 2. One can calculate it. That's whatever it is. Okay, can we calculate it? Right. How do you calculate it? So you can do this, right? You can do this, and you can calculate it, right? So a1 is 1, and a2 is, I don't know. It's minus 2. No, a naught. Oh, so a naught we don't have. So then you have to find a naught also. Right. Let's find a naught. A2 is a1 minus a naught. So please tell me what does it come out to be? So a naught is minus 1, and now I'm going to use this to find a of minus 1. Okay. Uh, this is 1 plus 1. Yes, so it does come out to be minus 2. And so this becomes plus 2, and this becomes 3. Okay. So it is 3, what Nagesh also got. Okay. Sorry. You have to, yes, yeah, that is we can apply the same. So Nandini, tell me, how do you calculate a of 99? Right, that's correct. Perfect. Then you get it right. Satya, is this method clear? Is this method clear to you? So you are saying that you can directly do it more directly. Are you saying that? Uh, sorry, you will get what? Mm-hmm. You mean from 97 onwards? Okay, yeah. So I'll get to that. Right. That's the other method. That's a more direct method. Yeah. But do you guys notice that there is something different in this method? Yeah. There is a certain leap of I don't know. There is a certain auxiliary construction happening here, and that is of a sub 0 and a sub minus. Some rules have been broken. Yeah. Satya and Nagesh, you see this, right? We sort of have gone back and introduced a sub 0 and a sub minus 1, right? I mean, what do you say? Legally, like, if you go by the rules, then a sub 0 and a sub minus 1 do not exist. Nandini, do you understand this, right? Yeah, so maybe I'm not saying like if, but some people could say that this is wrong. How can you write a sub 0? Like, maybe I'm just saying a school, in the school, maybe the school teacher would say, no, there is no a sub 0 in the question. But so in a way, but can any one of you explain why is it conceptually correct to to I don't know, consider a sub 0 and a sub minus 1? Uh-huh. Minus 7. 7. Okay. Huh. Um, No, that is right. It does give us a right answer, but then why is it conceptually correct to be able to do it? Anyone wants to take a shot at that? Because this method is very useful actually. In a lot of problems, it sort of becomes necessary. I've seen some modular arithmetic problems combined in this. It sort of becomes very important to look at the previous terms, like a sub minus, even though it's not given in the question. Yeah. So, well, it is not incorrect to do this because eventually you are replacing A1 by this thing, right? You are calling this A naught and A minus 1, but eventually the numbers that you're placing there are in a way that they give you the correct answer of A1, right? You're placing minus 1 and minus 2 or where something like that, right? Whatever. Something you're placing the correct numbers so that A1 comes out to be that thing, right? It comes out to be 1, right? So you have basically broken up A2 as A1 minus some new alien thing, yeah? But you're giving this new alien thing a number so that it matches with A2, so that A1 minus A naught does become A2, okay? So even though you're introducing a new thing, you're giving them the correct value so that they fit in the picture. So it's legally correct. Why is it helpful? Well, you can see it sort of kind of, helps you to kind of complete the picture. Let me just keep it at that. Here, it is not really necessary because there's a more direct way, but this is an interesting solution. Okay, let me keep it at that. So let us just go to the more direct way. Yeah, but this is a nice solution. Yeah, this is the thing that happens in discussions. You get these new thoughts, right? And new ideas come in. Right. So um, let's go to the more. So let me say the direct. Satya, would you like to tell us the more direct way? Maybe let's see how you have. Good. Okay. Nandini, do you see this? Right. This is interesting. This is nothing new. Did you observe this, Nandini? Did you observe this? Yes. So this is another interesting thing, right? Where the first 6 terms actually add up to 0. And this will obviously give you a more direct way. So as Satya is saying that this is 0, then obviously from A7 to A12 is also 0. And so your A whatever to A96 will be 0. And so this will just be finally be A97 plus A96, whatever, right? Sorry, why am I going back? 98, 99. And again, these 4 are easy because again, from the pattern you can calculate. I mean, just the first 4 terms. Okay, this is again just a different way to see it. There's another way to do it. Okay, uh, which is through a formula, but I'll get to the formula after some slowly. Okay. This problem is we didn't really need a formula. We're doing it through these things. Okay, good, interesting, nice, very good. Yeah. Something good. I'm happy. Yes, yes. Uh, whether they exist. Um, okay, so they do not exist in the question because let's say that okay. I mean, if in the question you are allowed to say an where n is an integer, then they exist. Then they are allowed in the question. But in the question, suppose it is given that n is bigger than or equal to 1. Okay, then in the premises of the question, they do not exist. right? But you can still introduce them and it is not incorrect. That is my point, right? And why is it not incorrect? Because you're introducing them, but you're giving them the correct values, right? The way you are introducing them, the a naught, you're giving a naught a value so that a2 is equal to a1 minus a naught. And so when you use them in the correct way, then there cannot be anything wrong. I mean, I am free to write this as x plus y. I'm introducing x plus y, and I'm free to write it as x plus y. No, nothing. That's an interesting thing. And so you have to the true, real correct reason as to why you can introduce them is also important to know. That's why I asked this question to everyone. That I mean, you just introduce them and it gives the right answer. That's a good thing, but okay, that's a hint as to maybe it is correct to introduce it. But one should give a logical explanation. So this is a subtle point, and I hope that Satya and Nandini, you guys also are understanding that point, right? Why is it correct to introduce a naught and a minus one and a minus two? Okay, like you could just write a2 as x plus y, xn plus yn, x2 plus y2. Nobody stops you from doing that, right? As long as you never give them the wrong values so that they don't contradict what you already have, then you can introduce. And we do these things all the time, especially this particular thing of going back, cyclic sequences. This is also sort of a cyclic sequence, but there are more special classes of cyclic sequences. But in either ways, we'll come to it. Please, if think about it, if you have any doubts later on also, any of you, please, I'll want to think about this. It's an interesting thing. So the point is that through the discussion, we are getting the different ways. This was actually some exam question, some aptitude test question, a good exam actually. CAT is a very good exam. So it's an exam in India. I mean, okay, so I don't want to resist them. It's a management exam and so on, but don't go into all that. It has a very good math section. Very good in the sense that obviously it's a subjective thing. What is very good, but it has some interesting questions. The math section. Okay, so this one just somebody in the I was in the library. Someone asked me at some point. Okay, so let's do an interesting question. Interesting for several reasons, I find. So, anyways, let's move forward. So moving forward, maybe I can ask, uh, find this. Okay, find this, and now I remove the initial conditions. No initial conditions. No initial conditions. Okay, try this. Okay, no initial conditions now. Okay? Okay. So now are there any ideas? This is a question. This one I just made up because I felt that there is more to this pattern than what the initial values are suggesting. This could also be a hint. And I think this question has a sensible answer in the sense there is a concrete answer to this. There is a numerical answer to this. No. So any ideas? This will slowly help us to transition from working with numbers and working with general variables. That is the point of maths in some sense, in try to prove things which will apply in general, not just to special cases where you start with one or two, right? Now you're starting with any two numbers, a1 and a2. What can you say? Is there some pattern? Second term and the last second term is what? Mm-hmm. So what is it? Oh, this is what the sum is. Is that correct? You're saying this is what the sum is? Ah, okay, interesting. Uh, so how come this A2 is remaining? Is that okay? Let's see. So can you explain why? Why? Uh-huh. So I see. Right. Like this. So then what about A1 and A2? This extra A1 and A2? That also we need to write. Oh, sorry. Yes, that gets cancelled. Right. Right. And then there's an extra A2 that remains. So 2 times A2. Oh, no, no, sorry. Yeah, no, no, right. That's correct. Yeah. I'm just trying to, it's wrong. Sorry. Yeah. So does everybody see this thing? Right? It is a similar thing to what the cancellation idea that we had earlier, but now we're not going into a minus one and a minus a, as we realize that it's not necessary for this problem. It doesn't really make it shorter also, but so essentially, so what Nagesh has done is you write this and then it cancels, right? The terms cancel. So this is the A3 part from A3. And then obviously this A2, this A1 cancels, this A2 cancels, A3 and so on cancel. This 6,665 is left. And this A2 is left. Okay, this A2, I mean, one A2 is left, right? So the final sum comes out to be this. This is not the answer, but is this correct? Like, does everybody agree with this? Yes or no? So is it clear, Satya and Nandini? Is it clear? Okay, so this is something that you have already done, but we're just asking because now it's like there are no numbers. So you guys are getting comfortable with these variables. That's a very good thing. Okay. So yeah, and by the way, this method and this thing of canceling, it's a very it's a general it's a thing it's a large part of the tricks of the trade. Okay. And these are called so that you can, if you want, look at some books and look at the contents, or you just Google, and because you should sometimes also Google things, but obviously you should try things on your own also. These are called telescoping sums. You can get some interesting things about this. Okay, on the internet, find some interesting problems. I'm not discussing it now as a top subtopic. I might do it at some point, but then there are so many things to do. Okay, so these are called telescoping sums. Telescoping in the sense sort of gets cancelled. Okay, so nullified, and the final thing is still simple. Okay, so this is a very good technique. All right, let's move on. But then, so what? How does it give us the answer? So as I'm saying, I mean, I want a concrete answer. I'm looking for a more concrete answer. I mean, it may happen that there is no concrete answer, but I'm saying, let's say that there is, or you try to find a more concrete answer. Yeah. So maybe this point has is gotten a little neglected. Is there still some pattern? Yeah. Is there still some pattern? Could think. Hello. Yeah. It's okay. So, so see, if you think you can do calculations once again. Try to calculate A3, A4 in terms of A1 and A2, because now you don't have the values, but still you can still calculate. You can still write. Oh, uh, hello. Oh, really? Wait, what is it? Hmm. I see. I see. Right. Yeah, because yeah, it got connected in Zoom, but in Google Meet it was. Okay. No, so what I was saying is you can still try to find a pattern by just calculating. Last time you had the values and you calculated. Now you don't have the values, but still write A3, A4, A5, A6, and try to find A4 in terms of A1 and A2, not using A3. Go to the root. Try to find A5 in terms of A1 and A2. Is that right? That's what you have to do, right? Because you don't have the exact numbers, but you can. But still, the whole thing is to be able to find the nth term, find the 10th term in terms of the first and the second term. That's the whole point. Try to do that and see some pattern has to come if there is. Right? Do it. So any ideas? Okay, let's see. So I mean, it. Mhm. A. Okay. Right. I don't know. It's a. This is a funny. This is an interesting thing. Right? It's like It's sort of like it's the sum of the two n terms, right? So it's like an minus two. I mean an minus one, which is sort of the middle term, right? It is the sum of the next term and the previous term. That is there. How you could use it, I don't know. Huh? Yeah, so that's sort of the wrong picture. I mean, anyways, leave it. Maybe if it's comes to use, then I can try to say. But just we do it, right? We just do it. So what is A4? Just calculate. A3 minus A2. Now what am I suggesting? Nothing. I'm just telling you to calculate. A3 is what? A2 minus A1. Just use the previous terms. That's what finding A4 means, right? Finding it using the smallest terms, right? So it's a minus of A1. That is something. Now calculate A5 and A6 using A7 in this way and see. Right? So I've written A4 as A3 minus A2, then I've gone back. A3 as A2 minus 1. Just plain calculation, nothing. No, not even, you know, trying to be smart. It's plain calculations. So what is A5? Tell me A5 in terms of A1 and A2. Sorry, minus A2. Other people, Satya Nandini, is this okay? Yeah, is this okay? Right. So then now I will suggest that you continue this and you calculate, and you will see that the old thing again happens. Okay, the same thing again happens, and then you'll be happy. Is that is that right? Okay, do this, work it out, find the final answer. You can do it from here also. Either ways, complete this. This is your homework. Okay? What I'm trying to say is that what I mean, this was just a question I may just made it up, right? In the sense when you guys were thinking, I somehow felt that this pattern that we are getting, these patterns, it's not due to the first two terms. It sort of seems to happen always. It follows from some in these kind of things. Okay. So now you complete. There is more I could say about this sequence. Yes. Uh, uh, you mean in you want like a conceptual reason or? Yes, we have not taken in numbers, right? Yeah. So it happens. I mean, yes, that's a good question because see the moment you see that A4 is equal to A minus of A1, so it means that after every three terms, it sort of becomes a negative. right? It becomes a negative of it, right? So that means that after 6 terms, it would become the same number. Right. That doesn't explain anything. All I'm just saying is that after the means the third term, I mean the fourth term becomes a negative. After every 3 terms, it becomes a negative of it. And that is possibly easy to explain once one looks back, but maybe not in the beginning. So we have A1 and then A2. Anything you take, any A1 and A2 you take, you sort of look at this gap, right? And you do A1 maybe, so this is 0, and you look at this gap, A1 minus A2, right? And basically this gap you are placing, yeah, this is just a silly system trying to think aloud. This gap you take and you put here, and basically this becomes your A2, right? And this gap here is maybe I just write A2 minus A1, as the gap is A2 minus A1, but the number is so this is A3, sorry. Okay. So all I'm just saying is that if you write A1 and A2 on the number line, then where is A3? Okay, it is here, right, where this gap is A2 minus A1, right? And then it will be simple. Again, you do the geometric thing, A4, you try to argue, you will see that you do prove that it's a negative of A1. It sort of will be exactly negative. These quantities you can fit that and you can find geometrically it's there. But yeah, is that a explanation? I don't know. It's just, yeah. I mean, this is a very interesting question. So I mean, then there are many interesting questions that can come from here. Okay, so one thing is which maybe I will say later is in terms of binomial coefficients, which I can see now. And one thing which I cannot see now, which maybe I'm asking to myself also, that if I want A1 to be, let's say, equal to A10, okay, and let's say if I want the pattern to repeat after 10 steps, or maybe let me make a prime number for a certain reason, okay, let's say I want it to repeat after 13 steps, so A14, okay, let's say I want terms to repeat after every 13 steps, okay, I mean, just a prime number, just in this for some reason. Can I make a recurrence relation which will satisfy this? Do you guys understand? This is not something that you can try it, right? But I mean, just because there's a bonus, I'm just thinking, right? Can I make a recurrence relation for which the pattern will repeat after every 13 steps, no matter from where you start? Yeah. Is this question coming? Is coming, right? That's the question that comes, right? So I made this recurrence and the pattern is repeating after every 13, after every 6 steps. Can I make a recurrence relation where the pattern repeats after every 14 steps? Or after every, that's separate question for a certain reason. After every 13 steps, for any n, is there an n cyclic recurrence relation for every number t, whatever, right? Those are some very interesting questions, and I've never thought about it. Maybe I'll think about it now. Okay, after I'll take some time and think about it. Okay? This is the things that come, and then there are some things, some generic things which I could say about this, but maybe not. I won't say now. Okay. Okay. This is all for us for the time being, but this will motivate us to consider. So what we are going to do the next time is something interesting, which maybe I'll not say directly, but indirectly. So it's okay, right? This is a discussion that we did, right? It's just different ideas coming and so on. Okay. The point is, let me give you this exercise. Okay. So you have this, so you know that there is this a plus b, right? And then there is number a square plus b square, and then there is a cube. So I was just thinking about how to introduce a certain way in which, a certain technique using which you can solve even equations like this, which may not have pattern. Or I mean, why am I even going to that? Let's say if I tell you just this, where it's the sum of the previous 2 terms. Now there is a pattern. Well, a pattern depends on how good you're at seeing patterns, right? But there is still a pattern in this, but there is no cyclic pattern. It keeps becoming bigger and bigger. You can understand that from the equation, right? Is there a method by which I can solve this directly? Right? Like from the previous, in the previous question, we sort of had a formula. Okay, if I tell you A of 10,000, you will say, no, A of 10,000 is just 10,000 divided by 6, whatever is the remainder, it is the A of that, whatever, A of 4 probably, or something, I don't know. So that's easy to tell, right? For this, can you tell A of 1,000? We will be able to tell in the next class. That is my goal. But I want to introduce it by something very fundamental. By which it is sort of be motivated. Usually I don't see it introduced. I'm thinking, experimenting, let's see. But that's the goal. We want to be able to solve those recurrences also, and maybe then start with some combinatorial questions which lead you to those recurrences. It's a Fibonacci recurrence if you can recognize it's there, no problem. But the question here is very simple. I mean, I want to look at this sequence. This is also like a sequence, right? It's a sequence of numbers. I mean, A and B, you can treat as numbers. You can put your numbers there, 1 and 2. It's up to you. That's not important. Any two numbers you can place. This is also a sequence, right? Can you write this using these two? Yeah. Let's see. Manipulation, algebraic manipulation. Can you write A cube plus B cube? I mean, so using these two is a vague thing, but I'm just keeping it vague. I can make it precise, but it would make it more complicated. Can you write A cube plus B cube using these two things? Somehow? Using A square plus B square and A plus B. You could put some things here. It's up to you. Want to try? Where? Oh, here. Am I right? Do you want to place it there in the last box? Okay, let me see. A minus B times A square plus 2AB plus B square. Yes, right. Sorry, that's what it has to be, right? But this will be A cube minus B cube, right? So yes, I mean that's almost. I don't know. Maybe this is better, right? But yeah, it's just, yeah, you understand, right? Good. Exactly. So that's what you have to do to get started, and then once you get started, then you get it. Yeah. This is all that there is. This, and well, now to satisfy my question, you can just say, okay, look, you can just do this. I've given you the main thing. Now you can just do this. So this kind of fulfills the conditions of my question, sort of. But it's an interesting thing. You're writing this thing using these two previous things. Is it clear with everyone? Yes, Satya, is it okay? This is just the identity, but we have now written it. So, I mean, this is the favorite identity. This is a very good identity, but now we can consider this identity, which just comes from there. It's nothing new, but this has this like a different perspective on the same thing. And it is interesting in the sense that it sort of has a recurrence to it, recurrence flavor to it, right? Here, this 3 is 2 here, and it is 1 here. This would some generalization, right? What would be the generalization of this? Knowing without knowing, in some sense. You can bet on this. You could think, this is what it should be. Means you have never done this, but by looking at this, you could guess the next one. And obviously you can check it. That's easy. Check. First question, is it natural to guess the next one now? Not a surprise, right? Yes, no? Okay, good, wonderful. And but you can easily check it also. I mean, if you can come up with it more directly is better, or you can, but you can check it. It's just a check you have to do. But then, please check this. And if you can come up with good explanations also, it's better. But obviously, in the worst case, I mean, the easiest way rather, not the worst, just check it. Just multiply out and check. Beautiful recurrence. Okay, maybe I rushed this a little bit, right? But we will see how this will be the foundation for all recurrences of that, of that an in terms of an minus 1 and an minus 2 of all recurrences, any coefficients you can put. We had 1 and minus 1 today. That this will be the foundation of all of them. That's the beauty of this recurrence. Okay. So this is where we stop. Okay? Now you can, yeah. If you have any questions, think and ask me. Yeah, think about them. Try. I'm not given much problems. Maybe just to complete few things and this thing, just give them a try. Okay. All right. I will send some references. I know we're just getting started. The main thing is I try to do things in a unique way. Okay. But then, yeah, so a general reference, which I did suggest, but there the flavor will be slightly different as much as I can remember. There is this introduction to counting. Okay. And obviously, if you want to buy this book, you can buy it. You don't have to buy it. You can also download it, in some places. And it's not even a necessary book. You can take any book in combinatorics. Okay. Introduction to combinatorics. Any book. You can look at Brualdi, wonderful book. Okay. But this is introduction to counting. There is this book, Introduction to Counting, by this Art of Problem Solving. This is a book. I mean, I'm also saying that because sort of a standard in the US, and it's a sort of, people want. It's a good book, and it's a very good for, especially for learning. It has a lot of illustrations and so on. But obviously, there is this more classical book, maybe Introduction to Counting and whatever probability. Maybe by similar name, there is a book by Brualdi, which is a classic, which is obviously I like more in the sense of pure combinatorics. It's not hard. This is a good book also. It's not, I'm saying that is one that is accessible. And it also has a chapter on recurrences. So I will suggest maybe Naga, especially you should go and go in and get in, okay, recurrences. Obviously, just online, if you see also a lot of things are there. So, but this was one book to stick to, one you can stick to. So yeah, okay. Go see, there are a lot of examples, problems, try the first few, see what is there. All right. Okay, that's it then. Thank you. This is the kind of discussions I want. It's explore the different